Now we have another problem, and this one is slightly more difficult because like it involves like a lot of concepts. Well, first we're asked to get like angular velocity, and we just got as data angular acceleration and time. So we know that we can use this like nice formula. That's omega is equal to omega 0 plus alpha t. From there we know that omega 0 is 0 because it starts from rest. So alpha is 2.6 times 6, and this is gonna be 15.6 radians over second. So there we go. That's A. Now for part B, we're asked through what angle has the wheel turned? Okay, so from there we know that we should use like this nice formula that we use since always. Plus omega 0 t plus a half of alpha t squared. We know that it starts from rest, so this thing is 0, and this thing is also 0. So we're just left with a half of 2.6 times 6 squared, and that's going to be 46.8 radians. Now, this is not my answer because I'm asked, well, this is just my answer, yes. Through what angle? Yes, that's part B. For part C, we're asked for the revolutions. So that answer that I previously got, I should use it once again. For getting 46.8 radians, I need to convert it into revolutions. We know that one revolution is 2 pi radians, and that is going to be, let me write it down here, 7.44 revolutions. And this is part C. And finally, I'm going to use an orange. For part D, what is the linear speed and total acceleration at that point? Okay, point 3 from the axis. Well, we know that the velocity is going to be r, the radius, times angular velocity. And we know both of them. So pretty much we have to substitute. That's 0.3 times 15.6. And the result of that is going to be 7.44. And this is the linear speed. Okay, this is one part of the result. For the, I'm going to call it D.1. Here you are. Now for the total acceleration, this is very, very interesting. We need to compute first the centripetal acceleration. So that's going to be, let me write it over here. Centripetal acceleration is equal to the velocity, linear velocity squared over the radius. That's going to be 446. No, what did I do? No, I just screwed, sorry. This thing over here, this thing is wrong. Yeah, this is 4.68. Yeah, sorry for that. So this is 4.68 squared over 0.3. And well, that is actually going to be a big number. That's going to be 73.008 meters over second squared. Okay, this is just a part of the result. I know how to get the tangential acceleration. For that, well, I know the final speed. That's 4.68. I know the initial one is 0. I know the final time. It's 6 seconds minus 0. So from there, I'm just going to get 0.78 meters over second. And the total acceleration, now I'm getting closer to my result, it's going to be the square root of 73.008 squared plus 0.78 squared. That thing is going to be equal to 73.012 meters over second squared. and this is actually my result. Okay, so I'm gonna call it d.2, and that's all for this problem.